welcome to Vedantu Malayalam channel. This is Sana Khan, your math master teacher, and I hope that you are doing super duper amazing. Today I have brought for you the last lecture of the chapter Matrices, where we are going to learn about transpose of a matrix, what are symmetric and skew symmetric matrices, and inverse of a matrix. Alright, now till now in the lecture number 1, 2 and 3, we have already completed these topics. We learned about what are matrices, what is an order of the matrix, the different types of matrices we have, equality of matrix, then addition, subtraction and multiplication of matrices. All of this we have already completed. Now in today's class we are going to learn about transpose of a matrix and inverse. These two concepts are very important because they are also going to be used in the next chapter, determinants. Alright. So, hope you are as excited as me to start today's class. If yes, do hit the like button, and if you are new on the channel, don't forget to subscribe. Now, let's learn about transposing a matrix. Well, basically, transpose sounds like transport, right? Now, transporting what? Transporting the matrix, the element of the matrix. What are we transporting here? Is my video lagging? Let me just check. Yeah, it's fine. Okay. Transpose basically means we are just interchanging the rows and the columns of a matrix. Okay. So, if your matrix is of order 2 cross 3, the transpose of matrix will be of order 3 cross 2. How come? Because the rows will become the column will become the rows. Let's take an example. Suppose I have a matrix 2, 4, 7, 1, 3, 2. Now this is a 2 rows, 3 columns. Now simply what I will do, I will write row 1 as column number 1. 2, 4, 7. Okay. Similarly, row 2 will become the column number 2. Okay. So I will write it as 1, 3, 2. So now I have my new matrix, which basically looks like this, and it has 3 rows and 2 columns, right? So like this we obtain transpose of a matrix. It is denoted by power T, or it can also be written as A dash. It is also denoted as A dash. Understood everybody what is transpose of a matrix? Let's take one more example. Suppose I have a matrix A of order 3 cross 2. What is A dash? A dash is basically, A dash is basically A transpose. So what will be A transpose? Nothing but write the rows as the column. Row number 1 becomes column number 1. Row number 2, column number 2. Row number 3, column number 3. Like that, I have a 2 cross 3 matrix now, which is the transpose of a given matrix. So, transpose is very simple. No logic. Just interchange the rows and columns. That's it. No calculations at all. Right? Okay. Now, here are some properties of transposing a matrix. Please note down carefully. If you are finding transpose of the transpose, you will get your matrix back again. How come? If you make rows as column, again you are transposing it, so you are making it again as a row. So you are getting your original matrix only, right? Similarly, if you have a constant, a scalar multiplied with the matrix, and you are finding out whole transpose, it is equal to the scalar multiplied with A transpose, because any number transpose is the number itself. The number does not changes. Next, when you are adding two matrices, whole transpose is equal to A transpose plus B transpose. But When you are multiplying two matrices, if you multiply A into B matrix and you find the transpose, it is not equal to A transpose into B transpose. Why? Because it is equal to B transpose into A transpose. The order changes. Okay, the order changes. It will be equal to B transpose first, A transpose later. Remember this property, it's very, very important. Okay. Now, let's do a quick question based on this concept. Here they are saying that A transpose is this, B matrix is this, then verify that A plus B whole transpose is equal to A transpose plus B transpose. Let's take the left hand side. Left hand side is basically asking about A plus B whole transpose. This is equal to, what is the A matrix? If this is A transpose, A matrix will be 3, 4, minus 1, 2, 0, 1. Okay. So this is 3, 4, minus 1, 2, 0, 1 plus minus 1, 1, 2, 2, 1, 3 whole transpose. So first of all, I will add them. 3 minus 1, 3 minus 1 is 2. Minus 1 plus 2, 1. 0 plus 1, 1. 4 plus 1, 5. 2 plus 2, 4. 1 plus 3, 4. Now I want to find whole transpose of this matrix. So which is basically equal to 2, 1, 1, 5, 4, 4. This is my left hand side. Okay. Hi Deva. Now let's find out our right hand side. So our right hand side is basically A transpose plus B transpose. A transpose is 3, 4, minus 1, 2, 0, 1. And what about B transpose? Since this is B matrix, B transpose will be simply make the rows as the column. So it will become minus 1, 2, 1, 1, 2, 3. Now you add them. So what you get? 3 minus 1 is 2, 4 plus 1, 5, minus 1 plus 2, 1, 2 plus 2, 4, 0 plus 1, 1, 1 plus 3, 4. This is my right hand side. Now you guys check, is your left hand side equal to the right hand side? Yes. 2, 1, 1, 5, 4, 4, 2, 1, 1, 5, 4, 4. This is equal to the left hand side. Hence proved. We have got the answer. Alright, understood. Next, let's learn about what are symmetric and skew symmetric matrices. Now, suppose I have a matrix. It can be of any order. And I find out transpose of that matrix. Okay. So once I find out transpose of that matrix, if I see that the transpose is equal to the given matrix, then I call it as a symmetric matrix. So if transpose of A matrix is equal to A matrix, then we say that A is a symmetric matrix. A is a symmetric matrix. Understood? Let's take an example. This is A matrix. Let us find out A transpose. A transpose will be row number 1 becomes column number 1. 1 minus 1, 5. Minus 1, 2, 1. 5, 1, 3. So when I make the row number 2, the row number 3 as column 1, column 2, column 3, I see that this is absolutely equal to the A matrix because A matrix is also same. So A transpose is equal to A matrix. This implies that A is symmetric. Clear to everybody? Similarly, What are skew symmetric matrices? A matrix is said to be skew symmetric if A transpose is equal to negative of A matrix. If the transpose matrix elements are equal to negative of the given matrix elements, then we say that it is a skew symmetric matrix. Now, in skew symmetric matrix, it is very interesting to note that if I put I is equal to j, that means aii is equal to minus of aii. That means 2 times of aii is 0. That means aii is 0. That means for a skew symmetric matrix, the diagonal elements will always be 0. Okay. For a skew symmetric matrix, the main diagonal elements will always be 0. Let's look at an example. Suppose this is A matrix. If you look at the diagonal elements, they are all 0. And if you find transpose of this matrix, what do you see? So we see that row number 1 becomes column number 1. 0, 1, minus 1. Row number 2, minus 1, 0, 1. Row number 3, 1, minus 1, 0. Now, if you look carefully and if you take out minus sign as common, so negative of 0 is 0, minus of minus 1, plus 1, plus 1 will become minus 1. Similarly, minus 1, 0, plus 1. Plus 1, minus 1, 0. So this is the new matrix we get, which is basically negative of the A matrix, right? What is this matrix? This matrix is nothing but negative of the A matrix, if you observe here, which basically proves it is a skew symmetric matrix. Okay, so hence proved our matrix is skew symmetric because A transpose is equal to minus of A. Alright. Now, some important theorems related to symmetric and skew symmetric matrices. For any square matrix A with the real number entries, A plus A dash is always symmetric and A minus A dash is skew symmetric matrix. What does that mean? Suppose you have any given matrix, any matrix you take, so always if you add A with A transpose, you will get a new matrix. This new matrix is always symmetric. What does that mean? It is symmetric means B will be equal to B transpose. Okay. Similarly, if you have a matrix and you subtract transpose of the matrix, you will get a new matrix C, which is always skew symmetric. Skew symmetric means that C and C transpose, C transpose will be equal to minus of C. Okay. This is a very important theorem because it is going to be used in solving some questions as well. Alright. Second theorem says that any given matrix can be expressed as the sum of symmetric and skew symmetric matrix. Okay. So any given matrix can be written as a B matrix plus a C matrix. Now what is this B matrix? This B matrix is A plus A transpose divided by 2. Similarly, this C matrix, which is skew symmetric, will be A minus A transpose divided by 2. So any matrix can be represented as the sum of a symmetric and a skew symmetric matrix. Symmetric matrix can be found out by A plus A transpose divided by 2 and skew symmetric matrix can be found out by A minus A transpose divided by 2. Okay. Now, a question based on this concept. Suppose they are saying that I have a matrix which is equal to P plus Q matrix, where P is symmetric and Q is skew symmetric. Then what is Q equal to? Just now I have told you the formula. A matrix is equal to symmetric and skew symmetric matrix. Any matrix is equal to symmetric and skew symmetric matrix. So P plus Q. Now what is P? P is A plus A transpose divided by 2. What is Q? Q is A minus A transpose divided by 2. Right? So this implies that Q is equal to A minus A transpose divided by 2. So let's find out the value of Q. Q is basically matrix A plus minus A transpose divided by 2. So matrix A is 2, 0, 5, 4. Subtracting the transpose 2, 0, 5, 4 and dividing it by 2. So we have 2 minus 2, 0. 0 minus 5, minus 5. 5 minus 0, 5. 4 minus 4, 0. Now divided by 2, you get 0 minus 5 by 2, 5 by 2 and 0. This is the value of Q. That's your answer. So what is Q? In the question they are asking you the value of Q, right? So Q is equal to 0 minus 5 by 2, 5 by 2, 0 matrix. Clear? Which option is the right answer? Option B is the right answer. 0 minus 5 by 2, 5 by 2, 0. Understood everybody? How you will find out P? How you will find out Q? Every matrix can be represented as a sum of a symmetric and a skew symmetric matrix. That formula we will use. Alright. Lastly, we have invertible matrices and how to find inverse of a matrix. First of all, what do we understand by inverse? If a matrix is multiplied with another matrix and the result is identity matrix. What is identity matrix? All of you remember where the diagonal elements are 1, remaining elements are 0, like this. Okay. So A cross B is equal to I. This implies that B matrix is inverse of A matrix. It also implies that B into A will be equal to I and A can also be called as B inverse. Okay. So first of all, B matrix is A inverse. Second of all, A matrix is B inverse because the condition is AB and BA should be equal to identity matrix. Okay. AB and BA both should be equal to identity matrix. Understood what is inverse? Clear? Okay. Now, there are two important theorems related to it. Number one, uniqueness of inverse. This says that if B is inverse of A matrix, then C cannot be inverse of A matrix. What does that mean? If A into B is equal to B into A is equal to I, this implies that there cannot be another matrix equal to I. This is impossible. So there exists only one inverse of every matrix. No matrix can have more than one inverse. Okay. Second theorem, A multiplied by B whole inverse is equal to B inverse into A inverse. It is not equal to A inverse into B inverse. Please remember, this is very, very important. AB whole inverse is not equal to A inverse into B inverse. It is rather equal to B inverse into A inverse. Clear? These two properties are related to inverse of a matrix. Alright. Quickly, tell me which option is the right answer. Everybody present. Rashid, Deva, come on, answer me. Matrices A and B will be inverse of each other if and only if dash. Which condition? Option A, B, C, D. Which is the right answer? Yes? Anybody? Which is the right answer? Hi, Shuhab. If matrices A and B are inverse of each other, what is the condition? Condition is AB should be identity matrix, BA should also be identity matrix. Then only we can say that A and B are inverse of each other. Okay? Chalo. Let's practice some questions to see if you guys are able to solve or not. First question, if A matrix is this, then verify that A transpose into A is identity matrix. Okay, let's find out. So, A transpose is basically sin alpha cos alpha minus cos alpha sin alpha, right? Now, in the question, they are saying verify that A transpose into A is identity matrix. So, A transpose into A is equal to sin alpha cos alpha minus cos alpha sin alpha multiplied with sin alpha minus cos alpha sin alpha. It is equal to sin into sin, sin square, cos into cos, cos square alpha. Then sin alpha cos alpha minus cos alpha sin alpha. Then we have cos square alpha plus sin, no. Next is row 2 column 1. So cos alpha into sin alpha minus sin alpha into cos alpha. Then we have cos square alpha plus sin square alpha. So what do we get? What do we get? Here we observe that sin square theta plus cos square theta is equal to 1. So we are basically getting 1, then this cancel, 0, cancel, 0, and this is also equal to 1, which is basically the identity matrix. So we hence proved that A transpose into A is equal to identity matrix. Okay. What is the real life application of matrix? You have in storing data in your computer systems, in your laptops. Array system is used, matrix system is used. Okay. Next question. If A transpose is this and B matrix is this, find A plus 2B whole transpose. Easy question. If this is A transpose, then first of all, A plus 2B whole transpose will be, what is A matrix? Minus 2, 3, 1, 2 plus 2 times of minus 1, 0, 1, 2 whole transpose. So this is basically minus 2, 3, 1, 2 added with minus 2, 0, 2, 2 2s are 4. So I am multiplying 2 with all the elements. Okay. Whole transpose So this will be basically, let me add here, we get minus 2, minus 2, minus 4, 1 plus 0, 1, 3 plus 2, 5, 2 plus 4, 6, whole transpose. So this is equal to minus 4, 1, 5 and 6. This is basically A plus 2B whole transpose. Easy? Very easy question. So first of all, we find out what is A matrix. We find out what is 2 times of B. We add them and then we find out the transpose of the given 2 matrix. Easy? Everyone can do it? Very good. Next question is, if A matrix is this, B matrix is this, verify that A into B whole transpose is B transpose into A transpose. Let's find out. Left hand side is first, A into B whole transpose. A matrix is 0, 1, 2 multiplied by 1, 5, 7. What will you get? Row 1, column 1, 0 into 1, 0. Row 1, column 2, 0 into 5, 0. Should I write? Wait, I will write. 0 into 1, 0 into 5, 0 into 7. Then 1 into 1, 1 into 5, 1 into 7. 2 into 1, 2 into 5, 2 into 7. What do you get? So we get our left hand side as 0, 0, 0, 1, 5, 7, 2, 10, 14. Alright. Let's find out the right hand side. The right hand side is B transpose into A transpose. B transpose is 1, 5, 7. A transpose is 0, 1, 2. Let's do the multiplication. 1 into row 1, column 1, 1 into 0. Row 1, column 2, 1 into 1, 1 into 2. 5 into 0, 5 into 1, 5 into 2. 7 into 0, 7 into 1, 7 into 2. What do you get? So we get 0, 0, 0, 1, 5, 7. 2 ones are 2, 5 twos are 10, 7 twos are 14. Did I find out the transpose? Oh, I forgot about the transpose. So sorry. So sorry. So here we have whole transpose, whole transpose, whole transpose. So basically, our answer has not yet come. Okay. So lastly now, let's prove it. So we have on the left hand side, we have 0, 0, 0, 1, 5, 7, 2, 10, 14 whole transpose, and on the right hand side we have 0, 0, 0, 1, 5, 7, 2, 7, 14. Okay. Now on the left hand side, if you see, if you find out transpose, what do you get? 0, 0, 0, 1, 5, 7, 2, 10, 14. Right? And similarly, here you get 0, 0, 0, 1, 5, 7, 2, 7, 14. Hence proved. Left hand side is equal to right hand side. Okay. So here, instead of left hand side, right hand side, you can also write that A into B whole transpose, and this is basically B transpose A transpose. Okay. And they both are coming to be equal, equal. So verified that they are same. All right. Okay. Next, very, very interesting question. Can you answer this? If A is a 2 cross 3 matrix such that A into B is defined and A into B transpose is also defined, then what is the order of the B matrix? Can anyone answer this question? Try. It says that A into B is defined. Do you remember matrix multiplication? Matrix multiplication says that, first of all, let us assume that B is of order R cross C. That is the order of B matrix. Okay. This implies that B transpose will be of order what? B transpose will be C cross R, right? Now, if A into B is defined, this implies that if A is a 2 cross 3 matrix and B is a R cross C matrix, then basically the row of B matrix and the column of A matrix should be same, right? So this implies that R is equal to 3. Similarly, A into B dash is defined. This implies that if A is a 2 cross 3 matrix and B dash is a 3 cross, and B dash is a C cross R matrix, then C and 3 should be same. C should be equal to 3. So this implies that B matrix is of order 3 cross 3. So the right answer is B matrix is of order 3 cross 3. Only then AB matrix and AB dash matrix can be defined. Alright. Okay guys, so we have completed the chapter here. Here is a super easy homework question for you. Comment the answer quickly below so that I will know that you're able to solve the question. Alright, let's summarize. What did we learn today? We learned to find out transpose of a matrix, which is basically interchanging row and column. Interchanging rows and columns. Now, these are the properties of transpose of a matrix. A transpose whole transpose is A matrix. K into A transpose is basically K into A transpose. AB whole transpose is B transpose into A transpose, and A plus B whole transpose is A transpose plus B transpose. Next, a matrix is said to be symmetric if A is equal to A transpose, skew symmetric if A is equal to minus of A transpose. Okay. And any matrix can be represented as half of symmetric matrix plus half of skew symmetric matrix. Alright. Lastly, we learned about inverse of a matrix. Inverse is basically a matrix which when multiplied to the given matrix gives you identity matrix. These are the properties related to inverse of a matrix, and remember, every matrix has a unique inverse only. It cannot have more than one inverse. Alright guys, so we have basically completed today's class, and if you have understood everything, quickly hit the like button. We can see only one like yet. Come on. 5 likes at least. Quickly hit the like button. If you want notes of the lectures, join our Telegram channel and you will be able to access all the notes, assignments and everything else. Thank you so much for watching. Do subscribe to Vedantu Malayalam channel for +2 and +1 physics, chemistry, maths and biology lectures. Do hit the like button if you enjoyed, and see you tomorrow. Thank you so much. Do let me know in the comment section which chapter you want to start next. Okay? Leave a comment, whichever chapter you want next, we will start that. Alright. Thank you for watching. Have a good day. Bye-bye.